And then once you find that, so you just kind of feel it to get the shape, right? And then what you're going to want to do is just cut this down. By the way, what am I cutting through? So it's the parietal pericardium, yeah, is what I'm cutting through. And the way that I'm going to open this up is like I'm peeling a banana. Wow, like that, okay? So here's the heart. I basically just pulled off, this is the parietal pericardium. Where's the visceral pericardium? Right here, okay? So this is the visceral pericardium, this is the parietal pericardium. I'm going to have to cut this all the way off. Notice all the fat around it. Kind of nasty, okay? And so what I'm going to do is I'm just going to cut it off sort of around in a circle.
That part we don't need any of that.
Nah. Okay? That, I'm guessing, is the thymus, part of the thymus. And there's lots of blood in here, too. It's kind of grody, okay? But anyway, I think that's part of the thymus. So anyway, so this is all parietal pericardium, right? Okay, so take that off. This top bit we're going to clean up a little bit more in a minute, but I don't want you to clean it until you figure out what you're doing, okay? We haven't talked about the path of blood through the heart yet. That's what we're going to be working on today in lecture. We're there. Did you start to try to do the blood flow homework? And it was like, holy crap, I don't know what I'm doing. Yeah. So we're gonna do that today. Okay. But even though you guys haven't heard that spiel yet, you're still going to be okay, because basically I'm going to show you how to kind of open this up. All right. And then you'll be able to sort of figure out what's what. So the first thing is the ventricles are the larger chambers in the bottom of the heart. The atria are these small chambers that also sometimes are called auricles because they look like an ear. So do you see this little lift up thingy? And then here's one on this side. These are the two atria, okay? And so what we're going to do is we're going to try to poke our probe down into an atrium and go all the way from the atrium down into the ventricle, okay? So I needed to cut off some of this just so that I could get at things, okay? And so the first thing to do, it's really hard to tell which side of the heart is right or left just by looking at it. So you got to kind of stick your finger in places and figure out what you're doing, okay? So by poking around, I've noticed that if I put my finger through this hole, I end up in an atrium. And if I put my finger all the way down, I get all the way into the ventricle. Wow. Okay, so what I'm going to do, I know, it's pretty impressive, is I'm going to put my probe through that hole, through the atrium, down into the ventricle, and pierce the bottom. Okay? Do you guys have a scalpel? Can you grab me a scalpel? Ah, there we go. Let's do that. Okay. So what we're going to do is we're going to cut not a perfectly straight line, but a bit of a curving line. Okay? And so the heart is fatty and slippery, so be careful while you're doing this, right? And I'm using a scalpel because it's too thick for scissors. Otherwise, I'd use scissors. And so I'm just cutting through a little bit at a time and kind of keeping track of what I'm doing, because I don't want to cut into the other side. I'm just cutting enough to get it so that I can open it up like that. Okay, so that's one side open. Right, now I want to get the other side open. So I'm going to poke around. And on this side, ooh, there's a hole. You can't see it, but I can, if I stick my finger in it, it's there. Right? So there's another hole. Okay? And once again, I'm going down through the atrium, down into the ventricle. Okay? And then once again, I'm just going to trace and I don't want to go so deep that I go all the way into the other side, but I need it to be deep enough that I can open it up like that. Okay? So basically what we've done now is we've opened up the two sides of the heart, the right side and the left side, and we've opened them up, and you don't need to do any other cuts. It's just two cuts, okay, so that you can see everything. All right? So what we're going to talk about today in lecture, one of the things we're going to do is we're going to talk about the path of blood through the heart. And we're going to start with the left side of the heart. Or, excuse me, backwards. We're going to start with the right side of the heart when we do that, okay? The way you tell the difference by looking, whether you're looking at right or left, you can't tell very easily from the outside. So you can't figure that out until you have it open. So now that I have it open, if I look at this and I measure how wide that is, how thick that muscle is, compared to how thick this muscle is, which one's thicker?
Left.
So the first one was thicker. So this is the left side. The left side has thicker walls than the right side. Okay? So that means we're going to start over here. Okay? And so we're going to go through the parts as if we're talking about the path of blood through the heart. Okay? Blood comes into, so this little chamber up here, our atria are filling chambers. Blood fills into them, but they don't have very strong walls. They don't pump very hard. Okay? So this is our right atrium. Okay? And the right atrium, blood comes into the right atrium through one of two places, either through the superior vena cava, which is here, or the inferior vena cava, which is there. And the way that I was able to find those is just sort of poking my probe around and being like, all right, well, that's the top one, so that must be superior. And if I poke my probe around, that must be the inferior vena cava. Okay? So those are the two vessels that can bring blood to the right atrium. So this is the right atrium. All right? As blood gets pumped from the right atrium down into the right ventricle, it passes through a valve. This valve is called the tricuspid valve, or the right atrioventricular valve. So it's this flap, basically. Okay? So the way that I remember that it's called tricuspid is tri-right. Both have ri in them. Tri-right. Okay? So tricuspid is on the right side. This chamber here is now the right ventricle. Okay? From the right ventricle, the blood then is going to get pumped out to the lungs. And it does that by going through a blood vessel, of course. And so to find that blood vessel, all I have to do is put my probe into my right ventricle and just kind of follow it this way. And eventually I'm going to come out of the top of it. And I'm going to cut it off just a tiny little bit and make it a little shorter just so that I can see it better. Alright, and so this is called the pulmonary trunk, which is an artery, because arteries carry blood away from the heart. And so we're carrying blood. The blood is getting pumped from the right ventricle out to the pulmonary trunk, where it's going to go out to the pulmonary arteries, which are going to go to the lungs. And then the blood's going to come back from the lungs through the pulmonary veins. And we're going to be on the other side of the heart. So that's the right side of the heart. Okay? One other thing I want to point out before we leave the right side of the heart is, do you see these little strings that are holding the valve in place? Those hold the valve to prevent it from flipping backwards. The whole point of the valves in the heart is they keep the blood going in one direction. And so these little strings hold that down. And these little strings are called the chordae tendinae. It means tensing strings. So cord, like string, cord, chordae. Tendinae, it holds them tense, right? So they hold the valve in place, basically. These are the chordae tendinae. And they're attached to little muscles. Do you see these little bumpy muscles right here? Right there, right there. I'm kind of lifting them up. Those are called the papillary muscles because they hold on to the chordae tendinae. And they're called papillary muscles because papilla means nipple, right? And so they kind of look like nipples, not really, but if you look at the model, they look more like nipples in the model than they do in the actual heart. Okay? So anyway, so those are papillary muscles. So, like I said, we come in through the superior vena cava and the inferior vena cava, and the blood goes into the right atrium. Then it goes into the right ventricle. It passes through, what valve was this again? Tricuspid valve, or you could say right atrioventricular valve, because it's between the atrium and the ventricle. Either one is fine. Okay? Then the blood is in the right ventricle, and then it heads this way. And in the process, it's going to pass through a valve called the pulmonary semilunar valve. I don't want you to try to find it, because you have to do more cutting. You do need to know it on the models, but you don't need to know it on the actual heart. Okay, so the pulmonary semilunar valve is going to be right around in there. Pulmonary trunk splits off pulmonary arteries, goes to lungs, comes back through pulmonary veins to the other side of the heart. So now we're going to be on the left side, okay? And so on the left side, so here's my left atrium, right? And if I start poking my finger through here, ooh, I found a couple holes. See where my fingers are pointing through? Those would be the pulmonary veins would be attached to those openings, because that's going to bring blood back toward the heart. Often you don't have pulmonary veins still. This is a pretty good heart that it still has pulmonary veins for you guys to look at, which is kind of cool. So this is the left atrium that we're looking at here, yeah? Once again, we have a valve. This valve is going to be called the bicuspid valve, or the left atrioventricular valve. Okay? It also has chordae tendineae that are held in place by papillary muscles. That's the same on both. All right? What chamber is this? The left ventricle. And so the left ventricle, I poke my probe up through here. Right? Wherever. So when you don't know where to go, just start poking your probe places and see where it goes. And you got to poke so you're not making holes. You don't want to invent openings, right? But if you find them with your probe, there you go. Okay? So that is, so this is the blood vessel that's attached to the left ventricle, which is the aorta. Okay, so that's the aorta sticking out the top. All right, so knowing the different ventricles and atria and the different valves is not so difficult, because once you remember that the left side is thicker than the right side, it's pretty easy. Okay, the thing that gets tricky is all the blood vessels. And so the blood vessels that you need to know are the superior and inferior vena cava, the pulmonary trunk, the pulmonary veins, if you can find them, or the hole where they've been cut off, and then the aorta, okay? And the way to remember those, I wouldn't try to memorize them from here. What I would do is I would try to think about the path of blood through the heart, which we're going to go over in lecture today, and think about where things go. And once you figure out where things go, the way that it'll be asked on the exam is I will put a pipe cleaner in something. Mm-hmm. So if I'm asking you for this one, I'll put a pipe cleaner through it, and I'll say name the blood vessel that the pipe cleaner is passing through so that you can see where it came from. So if you know the path of blood through the heart, you'll be able to figure out what vessel that is. Okay, so you don't have to necessarily just memorize them from the top. Okay, so since my probe is passing through there, which side of the heart was this? Left. And the left side, the reason that it's thicker is because it pumps blood to your whole body, whereas the right side only pumps blood to your lungs. So this has to travel a shorter distance, so we don't need as much muscle. And so since this is pushing blood to the whole body, what vessel must this be? Aorta. The aorta, right? Whereas if I put the probe through... Hold on. If I put the probe through there, it's going from the right ventricle up. That's going to be the pulmonary trunk. Okay? All right, so... you unfortunately, because I'm so behind in lecture, you didn't get the heart lecture before you see this. But hopefully, if you spend enough time looking at this today, when we do the heart lecture, you can sort of imagine, oh yeah, you can kind of think back to what you were looking at today. And then if you can come to Open Lab today, that would be great. Or if you want to come back on Tuesday, if you're free, you're welcome to come to lab on Tuesday. All I ask is just that you stay in the side room so that you're not getting in the way of the Tuesday people. But if you need to review your heart again, you're welcome to do that either in Open Lab today or on Tuesday morning. Okay? All right. Questions? We good? Okay. I'll do a second.